We will now derive the expression for the equivalent capacitance for parallel combination of capacitor. So first of all, let us consider three capacitors C1, C2 and C3 connected in parallel as shown in the figure. And this parallel combination of capacitors is connected with a battery having potential V. Now all the three capacitors are at same potential. Now we can write that these capacitor C1 at potential V, capacitor C2 at potential V and capacitor C3 is also at potential V. What difference there is? The difference is on the charge. Let capacitor C1 hold Q1 charge, let capacitor C2 hold Q2 charge, let capacitor C3 hold Q3 amount of charge. You know that the capacitance is given as charge upon potential. So from here we can write this charge is equals to capacitance into potential. So we can write Q1 is equal to C1V, Q2 is equal to C2V and our Q3 is equal to C3V. Now the total charge in the combination can be written as Q is equals to Q1 plus Q2 plus Q3. So we can write the total charge Q is equals to, in place of Q1 we will mention C1V, in place of Q2 we will write C2V, in place of Q3 we will write C3V. Taking V common, we can write Q is equals to C1 plus C2 plus C3 multiplied with V. Now what I will do, I will take this V to the left hand side. So we can write that this Q by V is equal to C1 plus C2 plus C3. Since it is a parallel combination, so we can write C parallel is equal to C1 plus C2 plus C3, and this is the formula for the net capacitance in the parallel combination. So in the parallel combination you can observe that the resultant capacitance is much larger than any of the individual capacitance. If you found this video helpful, then please subscribe my channel Researcher Rohan Physics to stay updated for more videos.